Welcome to our channel Maritime TV. Today our presentation is about positive displacement pumps. Onboard ships complete technical guide including all 10 safety devices. In this presentation we will see gear pumps, piston pumps, screw pump, vane pumps, diaphragm pumps, and safety devices. Let's start with definition and applications on a ship. By definition, a positive displacement pump traps a fixed amount of volume of a fluid in a chamber and forces it to the discharge side with every rotation or stroke, delivering constant fluid regardless of system pressure. These PD pumps have several applications on board ship. PD pumps are found throughout the vessel. It's critical for all fluid systems. Let's start with bilges. We have piston pump, diaphragm pumps. Also in engine room we have gear pumps, lube oil pumps, and fuel transfer pumps. Also in cargo hold we have screw pumps, diaphragm pumps, and cargo transfer pumps. Also in deck we have vane pump and piston pumps. So these key systems, which are fuel oil transfer, lubricating oil, bilges, ballast, cargo, hydraulics, and firefighting, each system has its own positive displacement pump type selected for the fluid's viscosity and the pressure requirements. So, what are the key points on this type of pump? Number 1, fixed volume per cycle. Means we have predictable flow. Self-priming. It can draw against the gravity. It can handle viscous fluid such as oils and chemicals. Fluid rate is constant despite pressure rise. Also, this type of pump must have relief valve so as to ensure safety. This cannot be deadhead. So how it works? Let's see gear pump, because this is common in most ships. First, look at here cross section of gear pump, where fluid is trapped between teeth and casing wall. These are two gears, drive gear and the driven gear. So this is the suction where fluid enters a pump, and this is the discharge. This is drive gear, this is hydra gear. So what are the steps from suction to discharge? Number 1 is intake. Fluid enters suction as gear teeth unmesh. Fluid enters suction when this gear teeth unmesh. Chamber's volume expand. Number 2 is the trap. Fluid is trapped between gear teeth and casing wall. The casing wall is a gear teeth. So fluid, after entering, fluid is trapped here. Number 3 is carry. Trapped fluid is carried around the outside of gears. The trapped fluid is carried around the outside of gears. Number 4 is discharge. Gears mesh again. This fluid is squeezed out to the delivery side. After gears mesh again, so fluid will go side also will go this side to the discharge line. Number 5 is repeat. The process repeat again from number 1 up to number 4. So what's the key principle here? Flow continues regardless of discharge pressure. This is why a relief valve is mandatory. So what are the types of positive displacement pumps? As we see, gear pump, because it is most common in a ship. Now let's check piston and screw pumps. Piston pump. A reciprocating piston alternately draws in and forces out fluid. That's mainly using in hydraulics, which is high pressure systems. So this is suction. This is suction valve. This fluid enter fluid chamber when the piston go downside. At this time, discharge valve is closed. When piston move upside, suction valve is closed and discharge valve is opening. So the fluid go to the discharge line. So how it works? Reciprocating piston draws in and forces out fluid through check valves. Uses, as we see upside here. Note that this type of pump produces a certain flow, so it requires air pressure. We will see next what is air pressure and its function. What is air vessel and its function. Let's see this screw pump. Screw pump use axial flow principle. These helical screws trap fluid in pockets, then move it axially to the discharge. It is in, it is out. It's inside of helical screws. What are the functions? Commonly used for fuel oil transfer, fixed as cargo, and lubricating oil. This type of pump produces low noise, also produce smooth flow that is ideal for viscous fluid. Screw pump, how it works? Helical screws rotate. As they rotate, fluid is trapped in pockets, moved axially to the discharge. Uses, as you see upside, same here, but note, this type of pump produces very smooth quiet flow. So this pump is ideal for viscous fluids. Also, let's see another types of PD pumps, which are vane and diaphragm pumps. Vane pump. Sliding vane principle. Spring-loaded vanes sweep fluid between rotor and casing. This is the working of this vane pump. As you see in the diagram here, this is the in suction, this is out discharge. This vane here. Mainly uses same as hydraulic power, fuel transfer, low pressure systems. So how this work? Spring-loaded vanes slide in rotor slots, sweep fluid between rotor and elliptical casing. Main uses hydraulic low pressure fuel transfer, as you see upside. Note that this type of pump is compact, also produce smooth flow. Also prevents wear over time. Also you see diaphragm pumps. This work by principle of flexible membrane. Flexible diaphragm flexes to expand and contract the fluid chamber. The suction side, discharge side. This is of course may be air or mechanical. Uses of this pump mainly for bridges, chemical transfer, service, and indoors abrasive fluid. Okay, how this works? Flexible membrane flexes back and forth expanding, contracting the fluid chamber, that is flexible membrane. As we apply force, this flexes back and forth. Also note that no rotating shaft seal. Fluid never contacts mechanism. So, we see about positive displacement pumps, but we have another type of pump called centrifugal pumps. So, what are the key differences between PD pumps and centrifugal pump? See this table. This shows key differences. We start with flow rates. PD pump, constant flow always, but centrifugal pump varies with pressure. PD pump is self-priming pump, but centrifugal pump, it needs priming. How about fluid type? PD pump, viscous fluid, just oil, rally, etc. But centrifugal pump, low viscosity only. How about pulsation? PD pump, reciprocating types, so this produces pulsating flow, but centrifugal pumps, none. These centrifugal pumps producing smooth flow. How about relief valve? Relief valve is essential to PD pump, but in centrifugal pump is less critical. How about dead head? In PD pump, dead head is dangerous, no flow head. But in centrifugal pump just spins. So, how about speed? Centrifugal pump is slow speed, but PD pump slow and centrifugal pump high speed. See these differences here. Summarizing, you can see constant flow always, self-priming, must have relief valve. This one, smooth, continuous flow, high speed, simple, needs priming. Critical, never detonate a PD pump. Pressure will rise until pump bursts or pump fails. Okay, now let's see about safety devices on PD pumps. Number one is a relief valve. This is most critical. So let's see key facts about relief valve. It is a spring-loaded valve on discharge side. Opens when pressure exceeds preset limits. Divert flow back to suction tank. Set below system. Maximum allowable working pressure always. Never isolate while pump running. Test and calibrate at regular intervals. This relief valve fits between pump and first valve. So this is a spring-loaded disc. Opens when discharge pressure exceeds set limits. That is this spring. This is a high pressure. When pressure is high, it's open. Return to the suction tank. Okay. Danger. Absent or stuck closed relief valve plus blocked discharge pipe burst, seal failure, or pump casing fracture. Let's see safety device number 2 and 3. We see air patching cork and suction strainer. Air patching cork. This is a small valve at highest point of pump casing. This, why we have air patching cork? Because we have trapped air inside the pump casing for paper lock, dry running, and cause hammering. So we open until still liquid flows, then we close. So we open slowly because sudden can release cause fluid spray. Also we have suction strainer. This is ready for filtration. Its function captures debris before it reaches pump internals. See here, we have suction strainer, suction pipe, suction strainer is bringing fluid to the pump. If this suction strainer is blocked or high vacuum on suction side, so cause cavitation. Also, this suction strainer meshed in 100 and 500 micron basket screen suction pipe from the pressure gauge in when its pressure is rise. Blocked. When it's blocked, high vacuum as cavitation risk. Also, you see air vessel and the mechanical seal. What is air vessel? Air vessel, this is a pulsation dampener. Compressed gas absorbs pressure surges from reciprocating pumps. This is a pulsating flow from pump. This one. Here we have air vessel. So, air vessel will cause this pulsating flow to smooth flow. So, before pressure pulsating, this gas cushion absorbs surges, dampens water hammered. After produce smooth flow. So, air vessel. Closed pressure vessel on discharge or suction side. Compressed gas cushion absorbs pressure surges. Smooth pulsating flow from reciprocating pumps. Check this. Check gas pre-charge regularly, cause ruptured bladder, no dampering. Also, you have mechanical seal. This is shaft leakage prevention. Two polished faces maintained in contact. This prevents fluid leakage along shaft. This fluid inside. We have this first stationary. We have this first rotating. This is thin fluid ring. No, never run pump dry. Seal faces need fluid clean for lubrication. You see here, lubrication. Dry running immediate seal faces overheat or fail. So, mechanical seal, two polished faces is rotating per stationary, prevents shaft leakage. Also, thin fluid films between faces provides lubrication. Never run dry. Seal fails immediately without fluid ring. Leakage visible. Urgent repair needed to lower the fluid ring. Also, we have wearing and drip tray. This wearing for protection and drip tray for containment. Wearing, this sacrificial protection. Replaceable ring protects casing worn in preference to expensive parts. This is diagram. Wearing details. So wearing is also called sacrificial ring. This is a replaceable ring between rotor and casing, so it maintains clearance. Also sacrificial. This ring wears first. That's why it's called sacrificial, protecting expensive rotor and casing. Materials made mainly bronze, carbon graphite, or PTFE. Replaced in pairs during even overhaul. Also check clearances. Also, we have this drip tray. Drip tray leakage containment. This is mandatory containment beneath pump sets, fire, slip, and pollution prevention. So to prevent fire hazard, slip hazard, pollution, corrosion, so non-comply. Rules: drain regular. Normal drain valve closed. So high level seal failure warning. Compatible materials. As you see here, this is a drip tray. So we have drain valve. So what's the deep tray? This is a containment basin and a pump, collects seal, whippage, and drips. Also prevents fire, slip hazards, and environmental pollution. Drain valve normally closed, open only to control the draining. Unused liquid in a tray or equal to error warning, seal, or flange failure. Also we have pressure and vacuum gauges. These are located in the level and the suction sides. These are mainly for the leveling and suction monitoring. So this is the pressure gauge on the level side, the discharge side of the pump. So pressure gauge monitors discharge pressure. When discharge pressure is high, it means we have positive or blocked valve. When low, is burst pipe or leakage. So use rubber on reciprocating pumps. Also, we have this vacuum gauge. Vacuum gauge, this is in the suction side. High vacuum blockage strainer or closed valve. This detects cavitation risk. Low vacuum is air ingress. Monitor continuously during operation. So we see the term cavitation. What does this cavitation mean? Cavitation, this is the pump killer. Vapor bubbles form and implode violently, destroying pump internals. Cavitation stages causes excessive suction vacuum, block the strainer or close the valve. What are the signs? Cracking and rattling sound, vibration plus fluctuating pressure. Possible damage, fitting erosion of impeller, casing, and wear ring damage. How to prevent? Clean strainer regularly. Ensure NPSHA is greater than NPSHR. This must be greater than this. To monitor vacuum gauge, act immediately on alarm. It's the same to this. Okay, let's see some out of all 10 safety devices. You'll see here, we have relief valve, we have air purging cork, we have suction strainer, air vessel, mechanical seal, air ring, lift tray, gear lock, delivery pressure gauge, suction vacuum gauge. All 10 devices work as a system. One missing or failed device can compromise the entire relation and endanger both. Thank you for your attention. But key best practice. What is the key best practice for positive displacement pumps to run safely? Never run PD pump against the quality discharge. The relief valve must be effective and working. Always prime pump before starting. Open air purging core, confirm state flow. Inspect suction strainer regularly. Monitor differential pressure continuously. Monitor both delivery pressure and suction vacuum gauge during all operations. Apply gear lock lotto before any maintenance. No exception, issue permits. Check mechanical seal. Any visible leakage requires immediate investigation. Drain drip trays regularly. Abnormal fluid level is a seal failure warning sign. Schedule overhaul, replace wear rings, yearly.